Welcome to the final phase of my term project for CPSC 651. This is the Big Data course at the University of Bridgeport for summer of 2019. And our project, as you can see here, was to do some kind of big data project. So what we chose to do for our project, because of the large number of readers and people interested in reading that read for pleasure, we decided to look at that kind of reader data. So we feel that really tracking the behavior of readers um, not only supports the online businesses like Amazon.com, but because of the large number of readers and the large number of books out there and things like that, it also gives us a really large data set that requires large-scale data systems to do that processing. And so what our project does is it's going to simulate some of these data analysis projects that would be done over these large sets of data just on a smaller set. Particularly, we're going to be looking at data from Goodreads.com. So as far as the problem definition goes, the data from Goodreads.com, it contains behavioral information from a large segment of the population. They have over 90 million users. They catalog 2.6 billion books. So they have a really, really large data set. And the interesting thing is because that data set is so large, they have, the traditional methods of using a relational database system just aren't going to work. They just break down too quickly. And so this scale of data is going to require something more like using the Hadoop platform or Hadoop ecosystem in order to process that data. And so that's what our project's really going to show, is that we can solve at least a subset of this problem. If we can solve a subset, then we can solve the full thing. So that data set that we have it's called GoodBooks 10K. It's actually open source. So what this is a user went and grabbed the top 10,000 books off Goodreads.com as far as their reviews go, and he pulled that into a data set that you could use for data analysis. There's about 6 million reviews in this data set, and the data set also includes not just information about the books and the ratings, but also which users rated the books, and then the tags that they use. So tags are used by Goodreads to determine different genres, but also to determine like really, really specialized things. So, 1940s war novels and things like that. There's a link right there on the slide to where that is obtained. You can also actually just Google, and it comes up pretty readily. It's the first result. So our proposed analysis was to use Hadoop to analyze this subset. We could use a larger set if we wanted to. Goodreads has an open API. You can go and call and get more data as you need. But we're going to limit it to just this 10,000 top books. It's going to use HDFS for the primary storage system. We're going to use MapReduce. MapReduce we're using largely to do some more basic, more simple aggregations, just to get a feel for how MapReduce works and the kind of Java that you need to write in order to get that to work. So we're looking at things like the average number of ratings, the number of ratings per book and the average rating per book. The number of ratings by user, so how many ratings the user contributed, and what their average rating is for their books. And then after MapReduce, we're going to actually use some more advanced techniques with Spark. This is largely because Spark's a little bit better suited for those more advanced analysis. We mentioned here that we were going to use SQL, Spark SQL for that. We actually ended up using Python, but it's the same idea. It uses Spark. Spark is basically abstracting away the MapReduce technicalities from us, and so we can do things a little bit quicker and easier. But in our case, we are doing, we proposed to get distribution by reviews and tags and users. That became really, really complex really quickly. So we actually chose to do something a little bit different. So the implementation details that we had. So the first thing we had to do is we had to prepare the data. So the data that we got, really, really good data, but there was a couple things that we needed to do. One, each of the files had a header row, so we stripped that header row off. And so that was part of the data preparation. The other one was really around the authors and the books file. So inside of the books file, it's all the details of the books, but there are certain books that have been written by more than one author. And in that case, those authors are usually comma separated. It's a comma separated value file. And even though those were escaped in the file by double quotes so that it should have worked, for some reason when we tried to parse it, it didn't split correctly. And so it was throwing things off because on those authors that had more than one author, it was basically shifting all the data. And so what we did here is I wrote a couple of different Python scripts, one that stripped the header, and then the other one that went ahead and it split the authors out of the books, and it created basically a lookup table. So we, in the books file, there's no authors in there now, but in the authors file, there's the authors and the book ID, so we can join them back together. To then process its data, I created one MapReduce project called GoodBooks. It had 4 different packages in there. So the book review average, user review average, your rating, and your rating average. So we actually did 3 things here you'll see in the results. We got the books and their count of ratings and the average rating. We got users, the count of ratings for the users and the average rating that they provided. And then we did these other 2. So really what this was is the first one was to get the year rating. So the publication year is contained in the books file. The rating is in the ratings file. So we needed to do a join to get that data together. And then we also were doing that so that we could then take and feed that to another process that gets us actually the count of ratings and the average rating per year, per publication year. So that particular section, the year rating in particular, had some complexities because we ended up having to do a join. And so we had the option of doing a mapper side join in MapReduce or a reducer side join. We chose to do the reducer side join, and that meant we needed to feed 2 mappers into a single reducer. And so that introduced a little bit of complexity through MapReduce. And then again, for Spark, we used Python for that. So PySpark is what we're using. And we used that in the previous data that we processed to get a list of top 10 books. The top 10 books, their rating count and their rating average, and then the top 10 authors as well, and their rating count and their rating, not authors, top 10 users, sorry, there's a mistake there, and their rating count and their rating average. We also were going down the route of doing that distribution of tags and users. It just became complex and we ran out of time for that. So here's sort of the results that we have. So the first 2 items here are the book review average and the user review average. And so up on the top section, what you see is this is a listing of the books, their count, and their average rating. So that first row is book number 1. It had 22,806 reviews, and the average review is 4.27, whatever. So right there, that would tell you that's probably a book that you want to see. You'll see that book come up here in just a second as well. But that's probably one that you would want to, that a lot of people would want to read or have recommended. Then down on the bottom, we see a really similar format. This, though, is the users. And so that top row is the user ID one. We don't know who that person is because the data set didn't give us user data that way, detailed data for the user. We just have the user IDs. But this is user ID 1. They've submitted 117 reviews, and the average rating that they give for books is 3.5. And so in that case, we could see, if we have somebody that really loves reading and they tend to rate every book high, you'd see something like a like a 4, 4.5, something like that. Whereas if it's somebody that they like reading but they're really critical, maybe their average is a 3.5, 3.4, whatever. So those were the first two sets of results. The next one is the one that we talked about with the year and the rating. And so this is the rating count and the average rating by publication year. And so you can see here the column on the far left is the publication year. Then the middle column is the rating count, and then the right side is the average rating for that publication year. And so what we're really looking at, and this is sort of a false, maybe a false correlation, but we're really looking to see did certain years produce really, really great books versus other years. Maybe we had a year that nothing really came out that was really that great. You can see actually these are all pretty close, 3.8, 3.9, 3.8, 3.9 as far as ratings, but there's a couple 4s there, and one's the 1994 is 4.2, so that would have, given the distribution, that would indicate, hey, that was actually a pretty darn good year. Of course, it all has to be weighted based on the fact that it has fewer reviews than some of the other years. So that was an interesting one to do, again, because of the complexities of doing the MapReduce for that particular analysis. And then the last one we did, these were the ones that we did with Spark. So with Spark, we used Python again. We actually got the top 10 books and the top 10 users. The way that we wrote this, it outputs the data both to HDFS as a regular data set so that we can use it again for other things. But it also printed out to the console and printed out in this format. And so there on the top you see the top 10 books. I mentioned earlier we had book 1 that had 22,806 records. That turns out to be the Hunger Games. So a lot of people like that. The interesting thing about this with Spark, we again had to do a join like we did with the previous one for year rating, but it made that join much easier because there's one function to do a join instead of having to write 2 separate mappers and then push both of those into a single reducer. So it made it a lot easier. Then down on the bottom, again, you see the top 10 users. So this is based on their rating counts. So user ID 1 is user 12874. They have rated 200 books at this time, and their average rating is 3.5. So this was actually really interesting. We don't have detailed information about the user. We probably could take that user ID, go back to Goodreads, and get more information, maybe a user ID or username from them. But the interesting thing about this is you can see that user number 1, their average rating is 3.5, but user number 2, who also did 200 reviews, is 4.21. And so if I was going to pick a rater, pick a critic of my book or whatever, I would actually want to go with user number 2 there, because they tend to give higher ratings. The user number 1 seems to be pretty low. Now, the one thing that we could do to improve on this is we can actually sort by 2 different items. So in our case, we were sorting by the rating count, but we could, in this case, sort on rating count and average rating. And so you'd see 1 and 2 inverted there because, to get the person that not only gave the highest number of ratings, but also had the highest rating average. So in conclusion, there's a lot of potential to get insights from this kind of data from sites like Goodreads. And again, they have a lot of data, but that large amount of data that they have, it favors using different techniques than what are typically considered legacy systems. And so as this project unfolded and the purpose of this project, it really did show that using Hadoop, using tools like Spark, it can efficiently handle the data set, and it can basically do the job that we would need to do that a legacy system might not be able to to handle. And so it was actually a really interesting project and really interesting to learn some of this stuff. It would be fun to keep going on it and see if we can get into the distributions and things like that. There's some questions I had about the data that I just haven't been able to answer yet, like seeing if there's a correlation on the rating, average rating, and the genre. So if people like science fiction more than they like fantasy or romance or mysteries, and see if that affects the ratings. But for the purposes of this, I think we've showed that the systems can handle it, and it is and handle it fairly well. So, and then just the final thing is the references that we had. Again, we got some information from Goodreads themselves, just to figure out how much data they have and things like that. They have some of that on their website, and then we also cite where we got the data from with Goodbook 10K, and that's just available on GitHub. So that it has been a great project and a great course. I've learned a lot and hope to keep going down this road. So thank you very much.